We are live.
Yes, sir. Good evening, everyone. Myself, Dr. Bhumi Bhatt, Assistant Professor in Electronics and Communication Engineering, Parul Institute of Engineering and Technology, Parul University. I take this opportunity to welcome Dr. Darshan Dalwadi, sir, Associate Professor, Electronics and Communication Engineering Department, Birla Vishwakarma Mahavidyalaya Engineering College, Vallabh Vidyanagar, Gujarat, to present the webinar on the topic Recent Trends in Wireless Communication Systems. Dr. Darshan has more than 12 years of teaching experience. He has achieved his doctorate degree from Gujarat Technological University and is an expert in the field of wireless communication systems. He has completed his master's in communication systems from GSET College, Vallabh Vidyanagar, Gujarat. He has completed his bachelor's in electronics and communication engineering from ADIT College, Vallabh Vidyanagar, Gujarat. His area of interest are wireless, mobile, and satellite communications, antenna and microwave engineering, wireless sensors, information theory and coding, signal processing, image processing, machine learning, and many more. He has published one book and has also proposed R&D proposals on recent trends in wireless communication system. He has published more than 20 papers in international and national conferences and also more than 23 papers in international journals. He has received Best Paper Awards also in many international conferences. He has delivered the expert talk in various STTPs and workshops. He has guided more than 7 students at master as well as PhD levels. So now I request Dr. Darshan Dalwadi, sir, to please share your expertise in the field of wireless communication system with us. Sir, please start the webinar.
Thank you very much, Bhumi Madam. Thank you very much, first of all, Parul University for inviting me. Let me share the screen. Yeah, I hope the screen is visible to all.
Yes, sir.
Yes. So recent trends in wireless communication system, right? So first of all, let me discuss what do we mean by wireless communication. So these are the first of all the presentation's outline. So first of all, we'll discuss the basics of wireless communication. Then after the current hot topic, as far as the wireless communications are concerned, so the starting with the cellular system. Cellular communication system is one of the part of wireless communication system. So we'll cover 5G cellular as well. We'll also cover 6G cellular. Then after we'll cover the narrowband Internet of Things, that is the recent trends as far as the wireless communications are concerned. We'll also cover low power wide area network. That is the wide area network is there, but it is working with respect to low power. Means battery lifetime is not an issue. So we'll cover that part also. The low power wide area network, what are the various sensors are available, what are the systems are available. Next part is it's the current hot topic as far as the developed countries are concerned, and even though there are lots of research ongoing as far as the country like Asian countries like India, China, and other. So that is a vehicle to everything, means the communications providing from vehicle to everything, means vehicle itself act as a base stations. So that is a V2X wireless. So we'll discuss that part. Long range wireless power means nowadays this is also the hot topic. As you know, that is mobile communications. As far as the mobile communications are concerned, wireless charging is there. So that is a short range wireless power, but we'll discuss long range wireless power. Then after we cover the wireless sensor network. That is a extended version of ad hoc network. So we'll cover that part. Later on, we'll move to the millimeter wave wireless. That is also the one of the prime aspect as far as the recent trends, as far as the 5G and 6G cellular are concerned. Millimeter wave and cellular system are linked to each other. And lastly, we'll discuss the software-defined radio. All right. So let's start with the first. What is wireless communication? Now, a wireless communication involves the transmission of information over distance without the help of wires. As the name suggests itself, wireless communications means without wire. So without the help of wires, cable, or any other form of conductors. So wireless communication is a broad term. right. So as far as the term is concerned, so it is what we can say that it's not a single term. Mobile communication is also the subset of the wireless communication. So it is a broad term, incorporates all the procedure and informs of connecting and communicating between two or more devices. So here underlying part is what? Two or more devices. Minimum two devices are connected and maximum can be anything. So it is a large number of devices. It's a recent trend as far as the device connectivity is concerned. Using a wireless signal through wireless communications technology. The transmitted distance can be anywhere between a few meters, right? For example, as you know, remote control, it's a wireless communications, it's a few meters and can be thousands of kilometers, for example, radio communications. It can be used for cellular telephony because as I already discussed in outline, the cellular telephone is a major topic or major subtopic as far as the wireless communications are concerned. Then wireless access to the internet. Obviously, the things are moving in nature, so internet facilities are also required. So it is a wireless access to the internet. Wireless home networking means the devices are operated with respect to your own voice. The voice command, voice operated devices. So that is a wireless home networking and so on. Other examples and applications of wireless communication systems are in terms of GPS units, garage door openers, wireless computer, mice, keyboards, headset, headphones. These all are the example. And even though currently the data are transferred as far as the wirelessly, as far as the satellite televisions are concerned, broadcast televisions and cordless phones. What are the advantages of wireless communication? The very first advantage is what? A cost effectiveness. As you know, the wireless communication, there is no infrastructure. So it's not like a dedicated infrastructures are required. So that's why it is a cost effectiveness. It's not like a, what we can say that in a wired line, the dedicated infrastructures are required, while in wireless, it's not like that. So cost effectiveness is one of the advantage. Flexibility. Nowadays, for example, means as day and day, the users are increased. So it's a flexible in nature. Currently, for example, whatever the number of the users, maybe the next day the users are increased. So it can support. Convenience, easy to use. Wireless communications, particularly we can take the example of mobile. So it is very conveniently it is used. It is easy to use. Yeah, speed. Speed is one of the issues. So whenever the users are moving, so it can achieve that particular amount of speed. Actually, speed is an advantage and as well as the challenges as far as the wireless communications are concerned. Accessibility, you can access the service anywhere, right? So accessibility is obviously it is one of the advantage. Constant connectivity. So it is the advantage and as well as the challenges. Why I said the challenges? Because if the users are moving in the hard to reach areas, so how the connectivities are there? So at that time it is the challenges, right? Particularly in what we can say that the cellular communications, where what we can say that your device depending on the signal strength. So as far as that, constant connectivity is the advantage and as well as the challenges. Both the things are. Now we'll discuss the one by one each and every topic. So 5G cellular, right? As far as cellular communications are concerned, so the current recent trends is what? 5G cellular. 4G device is already used, right? 4G service is already used by the user, but 5G is about to launch in some of the cities in India. It is launched. So 5G cellular. So why do we need 5G, right? For example, if you're having the 4G SIM card and 5G SIM card, so for what kind of requirement you want 5G? So we'll discuss that part. The first thing is what? As far as why do we need or what is the requirement? So the first thing is what? Mobile data traffic is rising rapidly and mostly due to video streaming. So if you are going for video uploading or video streaming, right? Video uploading, and if you want to, what we can say that the large number of file size, if you want to upload, at that time this 5G cellular is required, right? Particularly for downloading and uploading speed. And as far as the video uploading, the uploading speed is required, right? With multiple devices, each user has a growing number of connections. So as you know, as the number of devices are increased, the bandwidth is divided. So obviously this is as far as the 5G is concerned, the frequency range is higher. So if you are going for the large number of connections at that time, this will benefit. Internet of Things, as you know, Internet of Things, the devices are connected wirelessly through internet. It will require the network that must handle the billions of devices. So for that, you require the, what we can say that the data rate, and what we can say that the bandwidth. You require the large bandwidth. So this is also the one of the requirement. With a growing number of mobiles and increased data traffic, both the mobile and network used to increase the energy efficiency. So this is also the one of the requirement as far as this data traffic concern, right? So we require the 5G cellulars. Now this is a good slide as far as the who is interested in 5G. The source is from ETSI. ETSI is a good website, particularly developed by the European standards. So they have suggested that as far as the 5G, as far as who is interested, what are the various sectors are interested in 5G. So very first sector is what? Public safety, right? So this is one of the applications as far as the public safety is concerned. Camera capture the things, and in a small amount of time, it can send the data, right? Even though the notifications to the particular users. So this is a public safety is one of the prime objective as far as the 5G is concerned. Broadcasting media, broadcasting or oblique media delivery means nothing but broadcasting means announcement. So announcement kind of thing is there. One to all kind of communications. Sender is one and the receiver is all. So broadcasting means at that time the announcement kind of thing is there. So at that time data rate is required large because more number of devices are connected. So this is the green one is a very active as far as interested in 5G. This sky blue one is for active kind of thing, particularly for rail industry, automotive industry, and education. So as far as the industry 4.0, rail industry and automotive industry, and currently it is industry 5.0. So for that to connect the various machines and various devices of rail or let's say automatic industry, for that we require the fast, what we can say the data rate, right? So for transfer speed and means downloading and uploading speed we required higher. So at that time, this 5G cellular is required. Education sector is one of the sectors. As we know, as far as this pandemic situations, the online communication is essential. At present, the aeronautical drones, as far as this 5Gs are interested, it's currently using that. Health service as well as the well-being means medical devices and medical related services are there. Utilities, particularly for the institutionals, relationship and for that particular standards, 5G service is required. Factory automations currently industry 4.0, I already told you. Agriculture industry requires this service and mining industry. So these all are the applications as far which already what we can say that it is used and about to be used as far as the 5G cellulars are concerned. And particularly in developed countries, it will reach up to the active mode. In very active mode, it will be the launch, that kind of thing. Yeah, 5G cellular. So what are the basics associated with respect to 5G cellular? Yeah, so this is a good slide as far as the comparisons of 1G to 5G. So first generation, it is in around the 1980s, right? 2G, 3G, 4G, and 5G. That is in 2020. And look at the data rate, downloading speed particularly. So in 5G and 4G, the difference is 1 Gbps and 10 Gbps, right? Latency is the most important thing because latency means delay, right? In how much amount of time the things are enabled. If you are using the cellular phone, so in how much amount of time it will enable the service. So as far as the 4G latency is near about maximum latency is 98 milliseconds. So delay is 98 milliseconds, while in 5G it is near about 1 millisecond. So as we had already seen, the latency is the main difference as far as the 4G and 5G is concerned. So latency means device, right? Let's say for example, in any one particular device, right? You on the any service, for example, any if you are using your mobile phone and you use the internet service, for example. So in how much amount of time the page is available as far as on your screen. So that is nothing but the amount of delay, we can say that. So latency is a big difference as far as the 4G and 5G is concerned. So that is already I have told you. Fastest downloading speed. Potential downloading speed we had already seen 1 Gbps, and in 5G it is 10 Gbps. What are the various base station aspect? Yeah. So base station aspect point of view, here underlined word is there. I just explained the main part. 5G uses small cell technology. Now why it is like that? In 4G, the frequency range is lower compared to 5G. In 5G, what we can say that the bandwidth is higher side, or the frequency range is on the higher side. So as we increase the frequency, the wavelength becomes shorter, lambda equal to c by f. According to that aspect, wavelength becomes shorter. So if shorter wavelength, so that particular means what we can say that to catch the short wavelength signal, we require the obviously large number of antennas, right? So large number of antennas are required, or higher number of antennas are required between transmitter and receiver. So for that, some non-technical phenomena is there. It is called a size of pizza boxes are required. It is like a cell, right? So size of pizza boxes means different. It is a kind of that box kind of cells are required in multiple locations. So then and then 5G services are available efficiently. Otherwise, it is not efficiently, right? Means whatever data rate you want, if you want that particular data rate, large number or higher number of cells are required between transmitter and receiver, right? We'll discuss later on also. Yeah, so which technique is used as far as the technique is concerned? So OFDM encoding is used, right? OFDM encoding, that is orthogonal frequency division multiplexing technique, is used in 4G as well as in 5G. But in 4G, it uses a 20 megahertz channels. So this is a difference. While 5G use 100 megahertz to 800 megahertz channels. So both the techniques are same, OFDM, but the difference is that as far as the channel bandwidths are concerned, or as far as the what we can say the signals are sharing with respect to the channels. So it's a huge difference, 20 megahertz, and which is quite 5 times higher there in 5G, starting from 100 to, even though it reached up to 800 megahertz, depending on the applications. Yeah, this is one of the key point as far as the 1G to 5G. This is a good slide. This is from IEEE Access. Yeah, so the source is from IEEE Access. So it's a good slide as far as the comparison between 1G to 5G. Look at that. The technology as far as the 1G, I'm not going to discuss 1G, but see that 4G and 5G. CDMA is up to 3G. 4G use Wi-Fi, WiMAX technology, even though LTE, long-term evolutions technique is used. 5G use 5G NR. The NR stands for new radio. So new radio technology is used in 5G. IPv6, right? Local area network, wide area network, personal area network. So see, all kind of machines are connected in 5G. And see that in 4G, the less number of devices. This personal area network and wide area network, that is nothing but the large number of devices, small devices are connected. And it is synchronized with the what we can say that the base stations, right? Multiplexing technique, 4G is CDM and OFDM, but look at that in 5G. OFDM along with OFDM, BDMA. BDMA stands for beam division multiple access. So it is a new techniques, and lots of researchers are ongoing doing the research as far as the BDMA techniques. That is a beam division multiple access. Now let me explain in a small amount of time what is BDMA. Beam means what? Let's say, for example, you are having the 20 number of devices, and there is a one tower. So towers radiate the signals, send the signals. But in beam division multiple access technique, what happened? Each and every 20 devices are allocated a beam. Beam means like a focus. All right. For example, let's say, as far as in any competitions, particularly in singing competition or in any dance competitions, there is a beam kind of focus on the stage to a particular candidate. So that kind of focus is on the device as far as a beam division multiple access technique. So each and every device is having a beaming. Beaming means each and every device received the signals from the actual towers, right? So that is a beam division multiple access technique is used in 5G and even though beyond 5G. Data rate we had discussed, bandwidth, right? Architecture, MIMO and massive MIMO. So it is multiple input, multiple output, but what is the difference between MIMO and massive MIMO? In short, I can explain. MIMO is used for point-to-point kind of communications, while massive MIMO is used for point to multiple point of kind of communications. So I had already told you BDMA technique is used. beam division multiple access. So it is a beaming for all the device. So point to multiple point kind of communications are used as far as the 5G is concerned. This is a prime reason that we have achieved the fast downloading speed compared to 4G. Right? Voice over internet protocol is already there. Yeah. So this is a key points. Our main key point is multiplexing technique and architectures. Now beyond 5G is a 6G cellular is there. So 6G network will be able to use obviously higher frequency than 5G. What is the difference? So latency in 4G and 5G latency difference is up to what we can say that the 1 millisecond, right? But here even though lower than that, so see that the latency in the particularly number 2, see that number 2 point, the 6G is having a latency to 1 microsecond. So 1000 times faster than 5G, right? In a developed country, even though research are ongoing as far as the 6G is concerned, right? Now, what are the comparisons as far as the 4G, 5G and 6G techniques? So look at the data rate, 4G, 5G and 6G. So in 5G, 10 Gbps, in 6G, 1 terabits per second. So it's a huge data rate. But not only data rate, but look at the number 4 point that is called the mobility support. So mobility support means the users are moving. So at up to what amount of speed it can support what we can say that the internet or any kind of applications, right? So up to 350 kilometer per hour. So bullet train, 4G, 5G up to 500 kilometer per hour. But look at the 6G, it can support up to 1000 kilometer per hour. Means if you are traveling with a very high amount of speed, for example, bullet train or something like that, where the speed is very, very fast. So at that time, it can provide the communications, right, without any kind of interference. Satellite integration is not there in 4G, 5G, but it is there in 6G, and it is not partial, it is fully satellite integration is there. Artificial intelligence is also fully autonomous vehicles, means driverless car and things are work itself. So as far as the 6G is concerned, so full communications are there. XR, that is a extended reality. Nowadays it is augmented reality and virtual reality is there. But extended reality means what? It is a kind of hybrid approach, right? Means virtual reality and as well as a physical device are also communicate. So it is a hybrid approach. So it is a new approach which is not there in 4G, but in 5G it is a partial, but in 6G it is a fully. Means the physical device and augmented reality, both are communicated to each other, right? So in 6G it is there. Haptic communications, terahertz communications. So terahertz is already there in, because the data rate is terabits per second. So in 6G it is there. Architecture, MIMO, massive MIMO, and here it is an intelligent surface. It is a kind of hybrid architecture, right? It is a massive MIMO is also the one of the part, but it is a hybrid approach. Maximum frequency, so 10 terahertz is there, right? Now let me explain frequency range and what are the challenges. So 3G, we know 2 gigahertz, 4G 2 to 8 gigahertz, 5G there are 2 bands. 28 gigahertz is one of the band, and the second band is a 39 gigahertz band is there. 6G 95 gigahertz to support up to, for the satellite communication, it can support up to 3000 gigahertz. Means satellite integration is there due to terahertz kind of communications. But what happened? So it is clearly seen from 3G to 6G, the frequencies are increased. It is well known that as frequencies increase, wavelength are decreased. So this is the one of the challenge actually, as far as the researchers are there working under this umbrella as far as the cellular communications are concerned. So as the short wavelength is there, so we require the large number of antennas or cells for efficient transmission of the signal, because wavelength is short, so signals droppings are occurring. So we required what we can say that the large number of cells to overcome that dropping problem as far as the signal drop is concerned, because the wavelength is short. All right. Now, so this is up to the, this is all about the cellular communications. Now we'll move to the next wireless communications. That is it's a current hot topic called narrowband Internet of Things. So why NB-IoT? So one of the main reason as far as the narrowband Internet of Things is concerned. So look at this. That is optimized for low power consumption, 10 plus years battery lifetime. Means if you want to fit a device at one particular location, No need to recharge a battery up to 10 years. So the device based on narrowband IoT approach. It's a large battery lifetime, which is not there in cellular communications. So narrowband IoT is what it is for the battery lifetime. What kind of scenario as far as a narrowband IoT is concerned? So billions of connections are there. Near about 150,000 means 150,000 connections are there per cell. Means in one particular coverage area, 150,000 connections are possible. Right. So extended long range coverage means if you are provide the communication in tunnels or hard to reach areas, right? For that narrowband IoT approach is used. So deep penetration and long range coverage area, particularly indoors and underground. So for that, this narrowband IoT approach is used. It integrates. Now, this is the main advantage. It integrates into cellular system. So no need to. The things are clear. Means machine is there and it can integrate into itself a cellular system, right? So it is one of the part of the cellular system, right? Secure and reliable. So industry standards are there. So because it is a license based, narrowband IoT is a license spectrum. So that's why it is a secure and reliable. There are lots of machines devices are there, or let's say what we can say wireless protocols are there, which is what we can say the unlicensed band. So we'll discuss later on. So what is narrowband IoT? So it is also known as LTE, CAT NB1. This is a narrowband 1 approach. Low power wide area technology. It introduced in the 3GPP, release 13. In the release 13, and narrowband IoT is launched. As far as the mobile connectivities are concerned, so at the end of the 4G era, it was started, right? LTE-M and narrowband. This is a yellow one. I'm talking about this yellow one. So in this era, this narrowband IoT is started, and even though it is the major aspect or major what we can say that the wireless protocol as far as the 5th generation mobile communications are concerned, right? So this is as far as this is for the comparison with respect to 4G and 5G, where NB IoTs are there. Why narrowband? So narrowband is typically implemented in telecommunications technology to carry voice data on a limited number of frequencies, right? So it can carry a voice data, right? The size of message sent via narrowband technique utilize a lesser bandwidth than the cumulative bandwidth of the channels, right? So this is a narrowband. Word itself the answer. The bandwidth is narrow, so it's having a lesser bandwidth compared to the actual bandwidth of the channels. So as far as this technique is concerned, so it is under low power wide area. I already discussed the battery lifetime of narrowband IoT is 10 years. So it is a huge battery lifetime. So it is a low power, but it can cover the wide area, right? So wide area technology, right? Because it is integrated itself in the cellular communications, right? To develop to enable a wide range of IoT devices and services. These are the applications of narrowband Internet of Things. Smart metering, particularly gas and water, even though in United Kingdom, almost in every home, this gas metering and water metering use the approach of narrowband IoT, right? Consumer, white goods, people tracking. So as far as the, what we can say that the goods, consumer point of view, this is also the approach. Amazon used this narrowband IoT approach also. Agriculture environment, so land, environment monitoring, pollution monitoring, right? So animal tracking. So this is also the one of the prime aspect as far as the agriculture industry. Smart cities, smart buildings. So these are the applications where the NB IoTs, right, is already used and is about to be used, right? In the developed country, in majorly most of the applications, it is already used, right? Next is low power wide area network. So NB IoT is one of the part, but apart from NB IoT, what are the other approach? Because one of the problem associated with NB IoT is license spectrum. So if you want to work with respect to NB IoT, you require some license, or you require some implementations point of view, you require some permissions kind of thing, right? But what there are other approaches are there. So we'll discuss in this low power wide area network umbrella. So it interconnect the low bandwidth battery powered devices with low bit rate over a long range. It created for machine to machine. So machine to machine communications for that low power wide area network is required. And Internet of Things, in Internet of Things, narrowband is one of the part. Low power wide area network operate at a lower cost with great power efficiency than traditional mobile network, right? So obviously the cost is lower, right? And the power efficiency is higher because battery lifetime is huge, right? They are also support a greater number of connected devices over a large area. LPWAN can accommodate packet size. Now, what is the packet size? From 10 to 1000 bytes at uplink speed and up to 200 kbps, right? Long range varies from 2 kilometer to 1000 kilometers. So this is also one of the advantage. It can support up to 2000 kilometers depending on the technology. So this is all about LPWAN. What are the various techniques or technologies are available as far as the different LPWAN umbrella, right? So yeah, so there are two approach. One is called license approach and second is called unlicensed approach. So I already told you, or I already explained the NB-IoT as in the license approach. But apart from license, there are lots of modules are available, right? In unlicensed approach, each and every module, LoRa, Sigfox, NB5-7, weightless, these all modules are available. Particularly LoRa and Sigfox are widely used as far as academic is concerned. As far as academic is concerned, LoRa, the students means even though researchers can use the, we can say even though the department also provide the LoRa and Sigfox board for implementations of the various project, because advantage is what, both are under the umbrella of LPWAN. The difference is what, NB-IoT provide the umbrella under license category, by LoRa and Sigfox unlicensed. So this is the advantage, and that's why the academic and even though in industry, small scale industries are also already used, and even the major industries are also working in this LoRa and Sigfox approach, right? Students can develop the projects. So that's why I explained actually this is a slide. This is a good slide as far as a comparison is concerned. So license spectrum, I just use this two approach, LT and NB-IoT. These are widely used, and in unlicensed LoRa and Sigfox. So this is a comparison. So coverage area. So look at the LoRa, 157 dB and 149 dB in Sigfox. So right, NB-IoT obviously it is a license band, so it is higher than that. But in unlicensed, RPMA is also one of the technique where coverage is used. But yeah, we can use this technique. 157 dB is enough, right? As far as the coverage is concerned, as far as application is concerned. Bandwidth. So major difference: LT 1 megahertz, LoRa 125 kilohertz. Battery lifetime. Look at the battery lifetime in all approach, 10 plus years. So it's a huge battery lifetime. Throughput. LoRa 290 bits per second to 50 kbps. So it is higher than Sigfox. But if you don't want any, it is depending on your applications, you can choose the board. LoRa board, Sigfox board is available. Depending on the application, you can choose, right? Two-way data transmissions. So LoRa, it is depends. Sigfox, it is not there. So if you require only single-way communications or simplex communications, you can use Sigfox. But in two-way data transmissions, yeah. So LoRa is the depending on that, right? Security, LoRa 32-bit, and in Sigfox is 16-bit, right? Scalability and mobility support. So yeah, in LoRa it is there. Support is there. LBS support is also there. Module cost. So this is the cost from the developed country, let's from US. It is also available in India with the low, what we can say that the low scale countries, right? So low scale in the low scale editions, this LoRa modules are available, right? Yeah, this is a source from Core Wireless, so you can refer it from Core Wireless. Yeah, as far as the architectures are concerned, right? So this is a basic system architecture for both the techniques, even the licensed spectrum and unlicensed spectrum for LPWAN umbrella, right? So this is the basic architectures. So there is a what we can network server or cloud server is there. It's serving the signals to the stations, right? So this is a gateway, right? This is your end device. This blue one is the end devices, right? So here the user equipments are. Then look at the user equipments. 1,50,000 users are communicated in one cell. So large number of user base is there, right? So this is a basic what we can say that the architectures as far as the LPWAN is concerned. Yeah, what are the major applications as far as the LPWAN? Smart city, smart grid, smart buildings, agriculture, consumer smart. So it is almost equivalent to narrowband IoT. But the difference is that I already told you the difference. Licensed and unlicensed spectrum means students can work the project as far as these unlicensed spectrums are concerned, right? So develop the smart meters, agriculture based on this LoRa techniques, even the smart cities, or even doing consumer products, right? Consumer applications, the student can develop, or research scholar can work under this LoRa and Sigfox approach, right? Yeah, this is a good slide as far as the data rate and range is concerned. So this is a comparison of all different wireless technology. Source is Beartech. So I already mentioned the source. You can refer it from them in detail, right? So let's say, for example, this light blue is a cost is low, dark blue is a high cost. Obviously, in cellular cost is very high, and obviously data rate is high, right? 5G, 4G, and even the 6G, the high cost is there, right? But the main thing is what, as far as this slide is concerned, whatever your applications, based on your application, you can choose the what we can say the wireless technologies, right? For example, if you are dealing with 10 to 100 meter, you can use Zigbee or BLE. BLE is also the Bluetooth enabled technology. So you can use these techniques as far as this particular range. So first of all, you choose the applications for what kind of distance you want to send the data and receive the data. And based on that, you can choose this, what we can say, the technologies. License LPWAN, the data rate is higher side. Obviously, this is a license, so security is there, reliability is there. Data rate is on the higher side. Unlicensed data rate is lower, but it is not too much. But according to your applications, if you want the manageable or optimum data rate, you can choose unlicensed LoRa, Sigfox, this band, and look at the range. Range is near about 2 kilometers to 20 kilometers. So range is the large, right? It's a wide area network. So range is it is, even though it is a kind of thing, right? So it is a comparison with respect to cellular and unlicensed LPWAN, right? Fine. Yeah, if you are having any questions, you can type even though in chat box, and we can discuss later on. Now next is what? Vehicle to everything. That is a V2X wireless. So V2X wireless, that is a vehicle to everything, means the vehicle itself act as a, what we can say, that the station, base stations. So it is a vehicular communication system that supports the transfer of information from vehicle. In sender is a vehicle to the moving parts of the traffic system that may affect the vehicles. The main purpose of V2X technology is to improve the road safety, energy savings, and traffic efficiency on the road. See, each and every protocol. So this is the technology as well as the protocols. Whatever I explained in the today's session, all are the protocols. Means boards are available, or we can say that the technologies are available as far as the standards are concerned, right? The main purpose is road safety. So look at this figure. V2X communications. Yeah. So vehicle itself, a sender. Vehicle to vehicle communication is one thing. Vehicle to pedestrians means in that particular vehicle, if you want to send some information on some data to a pedestrian users, so that kind of communications are also. It's a bi-directional. Look at this figure. The arrows are bi-directions. Means vehicles are a sender, and at the same time, vehicle can be a receiver, right? So it is a kind of moving vehicles, mobile van kind of approach, right? A moving kind of things. Vehicle to network communications and vehicle to infrastructure communications. So this kind of communications are there, particularly in the V2X approach. So first of all, you have to select your application. Based on that, you can select the technologies, right? In a V2X communication system, the information travels from the vehicle sensors and other sources through high bandwidth, high reliability link. It allows to communicate with other cars, infrastructure, parking space, traffic light, and so on, right? By sharing information such as speed, these are some applications, right? Okay, sharing the speeds, other entities around the vehicles, the technology improves the driver awareness, and so on, right? Road accidents, fatalities, injuries. So this all kind of informations are sending. The technology also enhances the traffic efficiency by warning the drivers of upcoming traffic, suggesting the alternative routes to avoid the traffic. Yeah, this is also the good scenario, right? Or good approach as far as to choose the alternative routes to avoid the traffic and identifying the available parking space, right? So this all kind of informations are sending by the vehicles to the vehicles or to the pedestrians, and based on that, the applications, right? What are the various standards are available as far as the V2X categories are concerned? So in IEEE 802.11p, this is one of the standards which works under this V2X standards. What is this IEEE 802.11p? So it is the original V2X standard and it uses WLAN technologies, that is the wireless local area network. It links vehicle to vehicles and vehicle to infrastructure. So for this two category, this standard is designed, vehicle to vehicle and vehicle to infrastructures. When two V2X standards get close to each other's reach, the 802.11p standard doesn't require any communication device, right? That does not require any communications device for it to work, and such a capability makes it ideal in less developed areas. So it doesn't want any kind of communications device itself. This standard itself act as a device kind of thing, right? This standard exceeds the line of sight sensors such as radar and camera, and it delivers the information such as toll payments, collision warnings. If there is any kind of collisions are there. The key characteristics of 802.11p is it includes a low latency. So even though in this short communication the latency is low, so delay is less. So in a small amount of time, the information reach to the particular users. Short range. So obviously because it is a vehicle, the thing obviously large coverage range is not required. Why? Because sender itself a vehicle and that vehicle is a moving, so it can move anything, right? So long range is not required. So under 1 kilometer it's a short range, and it turns in the unlicensed 5.9 gigahertz band. So unlicensed means the things are available for researchers, and right, it is like an open access system kind of thing, right? So you can use this standards. It is unlicensed 5.9 gigahertz band. In addition to that, the standard delivers a performance without being affected by the weather conditions. Yeah, this is also the advantage. In weather conditions, cellular communication, there are huge problems. But in this, it can perform without any kind of affected by weather conditions such as fog, rain, snow. And the technology can scan the surrounding environment even in adverse weather. So this is the biggest advantage, because in weather conditions, particularly in rainy season, look at the amount of speed as far as the wireless is concerned. In wired it is okay, but in wireless, these are the one of the what we can say that the issue or effect as far as this weather conditions are concerned. But this standard and this communication, V2X communication, is free from that. So even though it performs well as far as the poor weather conditions, right? Second standard as far as this V2X is concerned, cellular V2X. First is IEEE and second is cellular V2X. This is alternative to 802.11p and the 5G Automotive Association and the Qualcomm support the use of technology. So it is providing by the Qualcomm. Qualcomm provide this technology, the cellular V2X. It uses the LTE approach. One of the key advantages of cellular V2X is that it includes the operational mode that user can choose from. So operational modes are there, so user can choose from their cellular device. The first mode involves a direct communication between vehicle over the PC or interface, right? PC-PHY interface, right? PC-PHY is a reference point where the user equipment directly communicate with other equipment. So it is a particular what we can say the reference point, right? So this kind of things the user can choose from the device itself, right? Cellular V2X is designed for active safety warnings such as road hazards warnings, other situation involving vehicle to vehicle and vehicle to infrastructures. So it is also used for that. Using C V2X system will also protect other road users such as cyclists and pedestrians. Other roads, cyclists are walking, what we can say that, right, the moving in a separate road, and pedestrians are moving in a separate. So that kind of things are communicated by using this PC-PHY approach, right? And that is integrated into the smartphone, right? So it will help detect the pedestrians and cyclists using the same road to prevent the accident and injuries. So if any kind of what we can say that, let me explain why V2X standards are providing, particularly in hill stations when the users are traveling with respect to vehicles, right? So there are lots of turnings are there. So it is very difficult to see the opposite end. So at that time, the notifications kind of things are required. So this kind of approach also helpful as far as this notifications approach to particular to the drivers at the both the end. So to overcome the accidents and all those things, right? Fine. Apart from direct communications over PC5, cellular V2X also allows the device to use vehicle to network communication. Network means main station, right? So vehicle to network communications is also provided. Apart from vehicle to vehicle or vehicle to particular infrastructures, vehicle to network is also providing, right? Once network receives the signal, it can send to a longer distance or something like that, right? Because this technology is for short distance or for short communication. But once the network is received the signals, received the things, then it can send to a longer distance. Next is a long range wireless power. Next. So this is a wireless power transfer methods, right? So there are two methods. One is a short range wireless power and second is a long range wireless power, right? So long range is typically a power transmission of hundreds of meters or across the kilometers, right? Transmission is using antennas to send electromagnetic beam. So electromagnetic beams are there to send like microwave or lasers. The limitation with using inductive coupling power transmission in long range is that magnetic field decays quite rapidly, right? So electromagnetic beams are used. So here magnetic fields are decayed. So when the distance between transmission and receiver is increased, so inductive coupling is not used. For that, the capacitive coupling or some other alternating approach of coupling is used. But inductive coupling is not used as far as the long range communications. For short range, it is okay. And that's why the electromagnetic beam is used for this reason. Long range power is having a two category. One is a near field power transmission and second is a far field power transmissions. Near field power transmission, one can observe the plane waves with very little to no beam divergence, right? So conversely, in the far field, the significant beam divergence is. Now, why beaming? So actually, I had already explained the beam techniques in BDMA. So whenever you are going for the long range, so beaming is required. Significant beaming is useful in far field. The beaming is not required for what we can say that the short range, right? So beaming is useful in this case also, right? What are the applications? So near field is a non-radiative technique. So there are two techniques. One is a non-radiative, that is a near field, and second is a far field, that is a radiative. So what is the application? What are the applications? So where the actual wireless power transfer. Let me explain the simple example. Wireless mobile charger, right? So to transfer the power wirelessly to your into your mobile, right? Particular, there is no wire associated with respect to that. So the application include the charging handheld device like phones and electric toothbrush. In electric toothbrush, it is also use RFID tags, induction cooking, and wireless charging. So application is that. So in this inductive coupling is useful with respect to this short range communications, right? Second is a far field. This is nothing but a radiative approach, right? Where beaming is used. So power is transferred in a one particular beam. Focus. Beam means what? Focusing. I already explained the approach in the initial of this session. Beaming approach, right? So what kind of beam? Electromagnetic beam is used, like microwave or laser. Laser I have already the known by all, right? The laser approach. The laser light is a visible, right? That particular light is seen by all, right? So it is a beaming approach. This technique can support the energy to a longer distance, right? And to the particular receiver. These applications for this type include also the solar power satellite and wireless power drone aircraft. So application in solar power satellites and wireless power drone aircraft where the wirelessly send the power to a long range. This is as far as the near and far field, in the long and short range. Next approach is wireless sensor network, right? Yeah, let me explain. So this is this wireless sensor network as far as the wireless communications are concerned, known by all, right? It is an extended version of ad hoc network, right? The sensor sends the things and send to a longer distance, right? It collect the data and send the data. For what kind of application? Let's say it can measure the temperature, sound, it measure the pollution levels, humidity, and wind. So sensors send the data, send to a central, what we can say the nearby locations, and then nearby location to a longer distance, right? It's a hybrid approach, right? Short communication and long range communication, both the communications are useful. So how the communication are established, how the sensor sends the data through nodes. So there are the hundred or thousands of nodes are installed in the various locations, right? And particularly in what we can say that in the sand, what we can say that the sandy data of the, let's say, the animal colony. So for that also the wireless sensor network is useful, right? Because things are moving, so send the data to a nearby location, that is called as a network, and from network to a longer distance. So what the node includes? Node means what? So it includes the radio transceiver part, means transmitting and receiving, with an internal antenna. So internal antenna is also there, or external antenna, a microcontroller, electronic circuit for interfacing with the sensors. So these all things are a part of a node, right? So battery or an embedded form of energy harvesting is also, in some cases, that kind of the nodes use the battery or embedded kind of form of energy harvesting is used, right? But generally battery is there, right? Architecture. So this is the basic architecture of wireless sensor network. So see, this the center part is a nodes. So this is a wireless sensor nodes. This node sends the data to a nearby. See, this node sends the data to a nearby to next, and next to next, right? Whatever. Suppose at left hand side the base station is near, so this node sends the data to a left hand side. If right hand side base station or nearby location is there, so it sends the data to a nearby right hand side locations. So in that way, it can communicate to base station only, means short range communications. But then to internet or then to a base station, to a long range communications are possible. So this is the kind of communication, the major part as far as the wireless sensor network is concerned. That is what the wireless nodes, right? Applications, area monitoring, healthcare, habitat monitoring. I already told you the habitat in a particularly in animal colony, right? Environmental, earth sensing, air quality monitoring, forest fire detection, landslide, water quality monitoring, natural disaster, machine health monitoring. Means you can choose your even the work of interest or work of project in this area. So that's why I include application in all the slides. So at least you are having some idea in which particular part we can start to work, right? Machine health monitoring, data logging, and so on. Next two techniques are millimeter wave and SDR. So let me explain that. So millimeter band, so it is works in 30 to 300 gigahertz. So it is a prime aspect as far as the 5G and 6G. Remember the 5G is having a 28 gigahertz and 39 gigahertz. So 30 gigahertz is including, and 6G is used from 95 gigahertz to 3000 gigahertz. So 300 gigahertz is also part of it. So millimeter wave directly or indirectly a part of 5G and 6G, right? So it lies between super high frequency and the far infrared band. The lower part of which is the terahertz band, right? Radio waves in this band, they have the wavelength. Obviously, higher frequency wavelength is very, very short. So 10 to 1 millimeter. Thus, radiation in this band is called millimeter waves. Why it is called millimeter? The wavelength. The reason is what? Wavelength. Lambda equal to C by F. So higher frequency. So that frequency is dividing. So that is nothing but the wavelength in terms of millimeter. So radiation in this band is called millimeter wave, and it is abbreviated as, if you found, let's see, you search in Google, you can find this MMW. MMW is abbreviations of millimeter waves. ITU, International Telecommunication Unit, designated for this band is extremely high frequency. That is nothing but EHF. What are the applications? There are several uses for millimeter waves, including communications, short-range radar, sensors, airport security scanners. So airport security scanners scan when you visit to the airport, the scanning devices are there. So that is nothing but it uses the millimeter. This short, very, very short range communication means it can detect a small amount of part, right? So various portions of millimeter wave band are being used in applications such as. So these are the applications, right? Of this 57 to 59 gigahertz is used for atmospheric monitoring, right? And climate sensing applications. So this band is used for this, and even though for emission in Earth atmosphere. IEEE 802.15 wireless personal area network defined operating 57. So what is the standard associated with millimeter wave? 802.15 WPAN. Under this band, it can use this millimeter wave, 57 to 66 gigahertz. 802.16, that is a WMAN, and also WiMAX is used in 10 to 60. And remember 5G, in their 5G, the major technology is also WiMAX is one of the contributor in cellular communications, right? So this is used, this approach, right, or band of millimeter. 802.11 AD, this is also used at 60 gigahertz band of this techniques. 5G, I have already told you, 24 and 39. Millimeter wave radar is used in short range fire control radar in tanks and aircraft. These all are some applications. Traffic police use a speed detecting radar guns. So whatever the speed detecting radar gun is there, it is also used the millimeter wave techniques used in the car band approach, 33 to 36 gigahertz. Clothing and other organic materials, in that also this millimeter waves technique is used. Not going into detail. The last technique is software defined radio, SDR. As the name suggests, I'm not going to in detail, but let's say some highlight of this software defined. You can define your radio, what we can say, the applications based on software. So flexibility is more as far as this software defined radio is concerned, right? So unlike in traditional system, it uses a radio device highly flexible and versatile. So compared to that, it is highly flexible, right? This is a basic diagram as far as SDR is concerned. Transmitter, receiver, radio front end, ADC, DSC means analog to digital and digital to analog, and then digital backend to host. So what is this digital backend? So digital backend includes this, what we can say that frequency range or broad range of frequency under 18 gigahertz, and it can use this front end of SDR. It can use the analog domain, and then it is converted into digital. Why? Because whatever the data sends, it is analog, and then it is converted into digital, and then it is transferred to the digital system, and digital system is there. So how the software defined works? So that digital data in the front end or in the back end approach, it is nothing but the field programmable gate array approach is used. That is a VLSI approach is used. So by using the field programmable gate array, it is a software to define the, what we can say, the radio application based on software, right? Are the applications. So GPS, medical, radar, machine to machine, even the IoT, network security, right? Okay. Yeah. Thank you very much to all. And if you are having any query, we can discuss. Any question?
So the presentation was very awesome. Many areas are covered nicely, briefly. And so those people who are learner, starting from bachelors to masters to researchers, everybody might have got benefit from this presentation. It was a nice presentation, sir.
Yes, thank you, madam. And any query or any questions?
So no queries, no questions.
Okay.
Okay.
So I hope it is completed within a time, right?
Yes, sir. Okay, sir.
Okay. Yeah.
End the presentation here.
Yes. Thank you very much. Thank you very much, madam, and thank you very much, Parul University, for inviting me as an expert to share my experience in front of you. Right. Thank you very much to all.
Thank you, sir.